what we're going to do now is we're going to take a look at applying the properties of logarithms that we had when we were doing regular logarithms, and we're going to apply that to common and natural logs. So all the same properties still apply. So that means if you have log base 10 or log base e, so common log or natural log, of a product, you can split it into two separate logs and add them. If you have a quotient, you can split it into two separate logs and subtract them. And if you have an exponent that applies to the entire inside, you can pull it out in front as a coefficient, okay? So first we're going to do an expansion problem, then we're going to do a condensing problem. All right, so this is really going to be a refresher from what we did last class. Okay, so on the expand problem, we're going to have natural log the whole time, and we're just going to write natural log throughout. We're never going to write log base e, okay? So the first thing we're going to do here is we're going to write that this is the natural log of, and because there's division right here, I can separate this into the natural log of one thing minus the natural log of another. All right, and the numerator goes in the first set of parentheses, so e cubed x, and then the denominator goes second, y squared. All right, and now when I look at natural log of e cubed x, that is really e cubed times x, meaning I can go ahead and I can split that apart as a product. Okay, so the product inside turns into the sum of two separate logs. So this is the natural log of e cubed now, plus the natural log of x. And then we still have that minus the natural log of y squared. All right, and now we can simplify even further. Since the beginning is natural log of e cubed, well, that's really log base e of e cubed, so it's same base. So that's really just equal to 3. Okay, natural log of x, there's nothing to simplify there because there are no exponents, no products, no quotients. Okay, but on this last one, this 2 right here, that's an exponent that applies to the entire inside, that can be pulled out in front. So I can write that this is minus 2 natural log of y. And this is our fully expanded expression, okay? Remember, e represents a number, it is no longer a variable. Okay, so that's an expanding problem. And if this had been just log, then it would have been log of e cubed x and so on and so forth. And we would have gotten a slightly different answer, but that's because the base wouldn't have matched on that very first log base e part of e cubed. All right, so the condensing problem. We have 4 log of x minus 5 log of y plus 2. So let's figure out how to deal with those first two pieces together, and then we'll come back to the 2 at the very end, okay? So the first thing I want to do is I want to work on condensing these two pieces. And remember, this first step is to look for coefficients to become exponents. So the coefficient is going to become an exponent. And again, I'm going to deal with that 2 later on. We're going to come back to that, all right? So this is really log of x to the 4th minus log of y to the 5th, okay? And again, I'm going to come back to that plus 2 momentarily, all right? Then we have subtraction in between these two, so I can make that into log of one thing divided by another because subtraction turns into division when I'm condensing. So I have x to the 4th, oops, x to the 4th over y to the 5th, okay? And now I have this plus 2 remaining. So now I'm going to backtrack and think about, well, how am I going to get this plus 2 into a logarithmic form? Now I know that in order to condense all of this together, we need to have all the same things. So I need another log, and keep in mind, this is log base 10. I need to fill in, well, what will go here so that log base 10 of that value would come out to 1, because this is really just a 2 times 1. If I can figure out what would make this expression right here equal to 1, then I just have 2 times 1, which is still a 2. And we talked before about how if the base of the log and the base of the inside are the same, then the answer is the exponent. So I need a base 10 in here, and I need 10 to the 1st power, okay? So what I really have going on here is I have log base 10 of 10 to the 1st, which would come out to 1, and then that 1 times the 2 out in front would just give me a 2. So now I'm going to have this. I'm going to bring that 2 up as an exponent and make this log base 10 of 10 squared, or I can actually just make that 100 right away, okay? And I don't really need to be writing this log base 10 down here, so I'm actually going to switch that out. Hold on one moment, please. I'm really just going to write this as log of 100, okay? Now that I have that, the addition in between, I can go ahead and condense this. I can take the inside that I already have, the x to the fourth over y to the fifth, and multiply it by the 100. So the final answer for this problem, we're going to have log of the numerator will get multiplied by 100. The denominator is going to stay just y to the fifth. And this is going to be our final answer, okay? So it's really hard to figure out what that log is going to be when you have just a plain number like this plain 2 right here. But that's something that you're going to need to figure out how to deal with. So the easiest way, again, is to just take that base that you know that you have, put that base right there. Always put it to the first power to start off, because if the bases match, the answer is the exponent, and we want 2 times 1 to still have a 2. Okay, so that's 1 expand and 1 condense. Again, all the same properties apply that did with regular properties of logarithms.